right, Unit 6, Lesson 7, Finding Unknown Coordinates on a Circle. All right, so notice and wonder, big and small. What do you notice? What do you wonder about this picture? So some of the things you might notice, the circle on the right is twice the size of the circle on the left, because you can tell by the radius. 2 is twice 1. Both of the triangles are right triangles. You have A and D in the second quadrant, so your triangles in the second quadrant. And your triangles have to be similar because these two angles are the same. They're both labeled with theta, which implies that they're the same angle, which means that this little angle, that reference angle we call that, that is also similar. Again, that is called a reference angle. Okay. Some things that you might wonder, is one of the triangles a dilation of the other? What might be the ordered pair for D? You should be able to figure out, I think we could figure out the ordered pairs for C, but maybe what's the ordered pairs for F? I don't know. There are other things that you could notice and wonder. All right, so let's take a look at 7.2 clock coordinates. Here is a clock face, and we have the length of the minute hand on the clock is 5 inches, and the center of the clock is at 0, 0 on the coordinate plane. So here's 0, 0. Determine the coordinates of the end of the minute hand at the following times. Okay, so we are looking at the minute hand is 5 inches long, okay, and we're looking at 45 minutes after the hour. So 45 minutes after the hour would be, so let's draw well, that's okay. So we're starting here, and 45 minutes would be here. So we've gone there, and we want to figure out the coordinates of the end of the minute hand. And so if the minute hand is 5 inches long, and let's just say units, their coordinates are units, right? So this would be, if this was our y-axis and here's our x-axis, then that would be the ordered pair -5, 0, because it is along the x-axis, along that horizontal, but it is 5 units to the left of the y-axis. All right, so I'm going to put the x and y axes back on there. So here's my y. There's the y-axis, and here is the x-axis. All right, so now we're going to look at 10. So that was over here somewhere. Oops, I want to do that color. That was over here somewhere, right? So then we're going to look at 10 minutes after the hour. Well, 10 minutes after the hour would be at the 2 o'clock hour. And so we are looking at that angle would be pi over 6, right? Because that is 15 degrees, or, I'm sorry, 30 degrees away. Remember, each of these quarters is 90 degrees. And so when you divide it into 3s, that's 30 degrees. right? And that's the same thing as pi over 6. Remember that if we want to convert 30 degrees to radians, we multiply by pi over 180 because pi and 180 are both semicircles. And then when you simplify that, 30 goes into 180 6 times. So that's pi over 6. Okay, so we are looking at that value would be the cosine of pi over 6. And then, oh, I'm sorry, not cosine. 5 times the cosine, right? Because the length is not 1 unit. The length is 5 units. And then 5 times the sine of pi over 6. And we can find those values by putting them into the calculator if we want. We also should know that that is the same thing if we look at our unit circle as 5 times square root of 3 over 2, and then 5 times 1/2, because square root of 3 over 2 is the cosine of that 30-degree angle, or pi over 6, and then 1/2 is the sine value. And then we can simplify that even further if we put that into the calculator. So if we put that in the calculator, we get 5 times the square root of 3 divided by, no, go back. Oh, that's not what I wanted. Let's move that up there. Let's do parenthesis square root of 3, and then move that cursor out, and then divide by 2. There we go. So that is about 4.3. And then 5 times 1/2 is just 2.5, or 2.5. All right, so that's how you could write that one. 40 minutes after the hour. And if you want, you have some extra clocks over here if you don't want to draw them all in the same place. Okay, which I might do here in a minute. All right, 40 minutes after the hour. So 40 minutes would be here at the 8, right? And so that would be 5 times the negative cosine of pi over 6, and 5 times the negative sine, because we're in the third quadrant, so they're both going to be negative there. Because pi over 6 is that reference angle. You could also look at it, if that might be a little too confusing. You could also say times cosine of 7 pi over 6, because that's that angle there. If you're looking at the unit circle, that is 7 pi over 6. And then 5 times sine of 7 pi over 6. Right? It doesn't matter what direction the minute hand is rotating in, because on the unit circle we go counterclockwise, but this is a clock, so we're going clockwise. But it still makes that same angle with the x-axis. All right, and so then we can plug in our numbers from our unit circle. So that's 5 times negative square root of 3 over 2, and 5 times negative 1/2. So our values are actually the same, we just have negative. So negative 4.3 and negative 2.5. All right, let's take a look at number 2. Okay, so now I'm going to get rid of this calculator for now. So now we'll do that. All right. So we have the minute hand on another clock is also centered at 0, 0 and has a length of 15 inches. So here is our clock with our center at 0, 0. Determine the coordinates of the end of the minute hand of the following times. So at 45 minutes after the hour, our minute hand is here. Remember that that length is 15. So we have negative 15, 0, because it hasn't gone up or down. So that coordinate is 0 for the y. And then for the 10 minutes after the hour, we're over here. And again, that is 15. So we have 15 times the cosine of pi over 6. And then 15 times the cosine the sine of pi over 6. All right, and so that's going to give us 15 times the square root of 3 over 2 and 15 times 1/2. And then we can plug those into the calculator if we want to, or you can leave them as, well, any of these answers really. So I'm just going to write 15 square root of 3 over 2 and then 15 over 2 just to consolidate a little. All right, let's take a look at 40 minutes after the hour. So 40 minutes, again, is over here, and that is a radius of 15. So we have 15 times the cosine of, and that is 7 pi over 6, if you're looking at it like the unit circle. And then we have 15 times sine, I keep doing that, sine of 7 pi over 6. And we've already done that once before, so we know that that is 15 times negative square root of 3 over 2. And again, you can use your unit circle as a reference for this. And so that is times negative 1/2. And then you can also write that as negative 15 square root of 3 over 2, and then negative 15 over 2. That can be your ordered pair. All right, let's take a look at part 3. At a certain time, the end of the minute hand of a third clock centered at 00 has the coordinates approximately 7.5, 7.5. So let's take a look at this. So here is my clock. And the end is at 7.5, 7.5. So that's going to look something like this. Because our coordinates are exactly the same. And so what does that tell us about that angle? Well, we know the angle has to be a 45-degree angle, which is the same thing as pi over 4, because that's an isosceles right triangle. When we draw that triangle, our height is 7.5 and our base is 7.5. So how long is the minute hand of the clock if each grid square is 1 inch by 1 inch? And so we are looking at the Pythagorean identity. Or Pythagorean theorem, really, not identity. So 7.5 squared plus 7.5 squared. And let's see what that gives us. I'm going to use a calculator for this. Let's clear that. All right, so we're going to do 7.5 squared plus 7.5 squared. And that gives us 112.5, right? But remember, Pythagorean theorem means that we need to take the square root of that, right? So the square root, because that really here, that's essentially, let me write it this way, might be better, is that radius squared. So then we have 112.5 equals that radius squared, right? So then we have to take the square root of both sides. And we're not going to put plus or minus because the radius has to be positive. But we are going to take the square root, square root of that answer. And we get about 10.6 is that radius. So our radius is about 10.6. Okay, so we're not going to do the are you ready for more? All right, around a Ferris wheel. The center of a Ferris wheel is 40 feet off the ground. I'm going to get rid of this calculator. And the radius of the Ferris wheel is 30 feet. Okay, so let's write down what we know. The center is 40 feet, so this is 40 feet total. And then the radius is 30 feet, so this little guy is 30 feet, right? That from the center to P. P is shown at 0 radians, so that's the starting point. Calculate how high off the ground point P is as the Ferris wheel rotates counterclockwise starting from 0 radians. All right, so we are going to take a look at as this is rotating. So I'm going to bring up an applet that we can take a look at so we can see how things are moving. Here we go. And there it is. All right, so we're going to look at how high off the ground at pi over 12. So pi over 12, there's 1 pi over 12. So there's our triangle. And so if we know that the height of that triangle is 0.26, so 0.26, that's the height of the triangle from its starting point, right? Or from that, not the starting point, but from the that center line, right? But we're already 40 feet off the ground, so we're going to add 40 to that. And so we get 40.26. Oh, that's for 1 unit. All right, so we got to fix that. We have to scale that. So let's come back to that. All right, so that is 0.26. But then we have to multiply that by that radius, which was 30. And then we need to add the 40 feet to it because we're already 40 feet above the ground. And so when we multiply that 30 times 0.26, you know what? We'll just do this. No. Instead of going to multiple apps, we'll just do this. All right, so we've got 0.26 times 30, and then we're going to add 40 to that. So we end up with about 47.8. So point P is about 47.8 feet off the ground. All right, so for pi over 2 radians, remember that pi over 2 is all the way up here, right? So you are an entire radius above the center. So that's the radius plus how high we were from the center. So that's going to be 70 feet above the ground. All right, and then at 5 pi over 6, which is the same thing as 10 pi over 12, we're right there. And that's going to be that y value, right, the sine value, times 30 because the radius is 30, not 1 for the unit circle, right? So we've got 30 times that 0.5, which is the sine of 5 pi over 6. And I probably should have written that up here. This was the sine of pi over 6, right? Plus that 40 feet that the Ferris wheel, the center of the Ferris wheel is off the ground. All right, so half of 30 is 15 plus 40. So that's going to be 55 feet off the ground or above the ground. And then finally, 5 pi over 3. Well, that is going to be the same thing as 20 pi over 12. So let's go up to 20 if it lets us. There, it did. Good. I don't know why it wouldn't have. Okay, so 20 pi over 12. So again, we have 30, which is our radius, times that y value, which is negative 0.87. And then plus that 40 feet that the center was off the ground. All right, and then we're going to multiply the 30 times the negative 0.87, and then we're going to add our 40 to that. And so it is about 14 feet off the ground when they're down there at that point, which makes sense because this little bit here would be 10 feet. And so it makes sense that they'd only be a little bit further up off the ground. All right, so as P goes around the Ferris wheel, estimate which angles of rotation put P 60 feet above the ground. So we know that this was 70 feet off the ground. So we are looking at 60 feet off the ground. We know that it's going to be higher than 5 pi over 6, which is the same thing as 10 pi over 12, because that was only at 55 feet, and we're looking for 60 feet above the ground. Right, so it's going to be somewhere between that 5 pi over 6 and pi over 2. We know that, right? So between pi over 2 and 5 pi over 6, because pi over 2 was 70 feet above the ground, and 5 pi over 6 was 55. Was 55 feet above the ground. Oops. And then we also know that somewhere between pi over 12 and pi over 2, right? Because pi over 12 was 47.8 feet. Oops. And pi over 2 was 70 feet. Right, and so if we look, we're looking for 60 feet, and we know that the original height was 40, so we need to add another 10 to that height. No, another 20, sorry, to that height. And so we are looking for 20 to equal 30 times something. So if we're looking 20 equals 30 times what? I don't really want to use X there, though. I'm going to use A. And so A would have to be 2/3. And so that one's pretty close to 2/3. 2/3 is 0.666. So it's going to be fairly close to pi over 4 if you're looking at the unit circle. Now, we're not going to get the exact answer, but somewhere around pi over 4, and then 3 pi over 4. Right there. Not right there. Right there. Because those are the closest. Oh, I meant to say equals. So 0.66 is A. So it's going to be somewhere around pi over 4 and 3 pi over 4. It's not exactly those, because those won't be quite 60. They'll be a little off, but it's pretty close. All right, and then you can take a look at the summary if you want to.